Okay, we're going to review the practice test on law of sines and law of cosines. And number 1, it gives us a is equal to 3, b is equal to 4, and c is equal to 6. And it asks us to solve for angle b. So I'm always going to try to visualize a triangle. I'm going to say this is 3, 4, and 6. So this is A, B, and C. Now, I know that you can go ahead and plug into a calculator or an equation and not write the triangle out, but I think that it's going to help to get better at doing all kinds of problems to visualize it. And we're looking for angle B. So since I don't know 2 of any of my letters, I know that this can't be a law of sines problem. And since I'm looking for angle B, the only law of cosines is the b squared equals a squared plus c squared minus 2ac cosine of b. Now, this is a good one to start off with because people make an algebra mistake a lot here. I know all of these pieces. I know B, I know A, I know C, I know A, I know C. The only one thing I don't know is B. That's the unknown. This is what I'm solving for. So since I know everything else, I can plug in and say B is 4. So 4 squared equals A is 3. 3 squared. C is 6. 6 squared minus 2 times 3 times 6 times the cosine of b. So 16 equals 9 plus 36 minus this all becomes 36 times the cosine of b. Now you cannot subtract these two 36's. This is attached to the cosine of b. You have to keep those together. So when we continue to simplify this, we get 16 equals 45 minus 36 cosine b. Subtract 45 from both sides, and you get minus 29 equals minus 36 cosine of b. Divide both sides by minus 36, and you find out that the cosine of b is going to equal 0.8. And now you cosine inverse both sides. So b is going to equal the cosine inverse of 0.8. And you get b equals 36 degrees. Okay, question number 2 says solve the triangle. So I'm going to put in what's given. We're given angle b. We're given A is 6 and C is 12. I don't know 2 of any one number, so I know I'm going to be in a law of cosines, but I'm going to draw the triangle first. It's not that important if you draw it to scale. It helps, but as long as you get the triangle labeled with the letters in the right spot, C is across from the angle, A is across from its angle. And now I'm going to look and solve for this one first, B, because I know that if I write this equation, a squared plus c squared minus 2ac cosine b, the only thing that I don't know is b. Okay, so we plug in our a, our c, and we get this long expression, which is just a number. So b squared ends up being 130.7 when you do 6 squared plus 12 squared minus 2 times 6 times 12 times cosine 70. And so you square root both sides, and you get b is equal to 11.4. And now we need angle A and angle C, so we can jump over to law of sines. So the sine of angle B over side B equals the sine of angle A over side A. So sine of 70 over 11.4 is going to equal sine of A over 6. This is a 6. And if you multiply both sides by 6, then the 6's cancel, and you get that the sine of A equals 0.494. Then you take the inverse sine of both sides, and you find that angle A is going to have a measure of 29.6 degrees. Now if you round a little different, it's fine. So we're going to put 29.6 degrees. And then we know, part of why I like to add these up this way, that this column has to add up to 180. So if we do 180 minus 70 minus 29.6, we find out that C is going to equal 80.4 degrees. That triangle is solved. Okay, so I've drawn out the things that we know on number 3, and we're going to try to solve this triangle. Again, we don't know two of the same letters, so we're going to use law of cosines. And, well, actually, we don't need to use law of cosines because where we stack these up, if we know two angles, we know we can quickly get this third angle. That third angle is going to equal 80 degrees because these have to add up to 180. That's the fastest way to do that step. Now, since I have both of the C's, I can jump right into sine of C over C equals sine of B over B, or sine of A over A. Either one. We'll do sine of C and B. So sine of 80 over 5 is equal to sine of 40 over B. Now, when your variable is on the bottom, on the denominator, I suggest that you cross multiply. You make less mistakes. So we're going to do B times the sine of 80 is equal to 5 times the sine of 40. And we divide both sides by the sine of 80. And that cancels the sine of 80 out, and we get that B is equal to 5 times the sine of 40 over the sine of 80, and B comes out to be 3.3. And now we can do A, sine of C over C equals sine of A over A. Same thing we're going to plug in. Sine of 80 over 5 is equal to sine of 60 over A. You're going to cross multiply, and you're going to get A times the sine of 80 equals 5 times the sine of 60. Divide both sides by the sine of 80, and you'll find out that A is equal to 4.4. Okay, here is number 4. Determine how many angles can be drawn. So I'm going to put my angle A in. If I'm given one angle, I'm going to put it to the bottom left because I think it's easiest to visualize. So the side across from that angle is going to be my A side, that's 6. The side adjacent to it is going to be my B side, that's 7. Okay? Now, what you have to do is you have to compare the opposite side to the adjacent side to this angle that you're given. If the side across from the angle is less, if it was bigger, if A was bigger than B, so if this 6 was bigger than this 7, then we'd have one triangle. But it's not. The 6 is less than the 7. So what we have to do is we have to look at this 6 and compare it to the height of the triangle. And I can get the height of this triangle because when I drop this height, makes it perpendicular, I've just made this right triangle. So this height is going to equal 7 times the sine of 35. Right? Because the sine of that 35-degree angle is going to be the opposite, the h, over 7 in a right triangle. And in this case, that height comes out to be, the height comes out to be 4. Since this side, this A side is 6, and 6 is greater than 4, that means that the side across is bigger than the height. What that means is that I'm going to be able to make two triangles. I'm going to be able to make this big triangle here, with that side being 6, and I'll erase my height. You can also make this same triangle. We have a 7, a 35, but now that 6 can come back down this way, and my B will end up this corner. That will be B, where this is A and C. And that's 6. So I can make two triangles. Now, with the law of sines, you're going to solve for the first one. The law of sines is always going to give you the bigger triangle, okay? Because you can't get this triangle in here, this B angle, right? Sorry, the 35 goes with the A. But this B angle here, that's bigger than 90. B is going to be greater than 90, and you can't do the sine inverse to get something greater than 90. So we're going to use law of sines and solve for this top triangle. We're going to say that the sine of A, sine of 35, over A, so the sine of 35 over A, but we'll just put A in, sine of 6, is equal to the sine of B over B, which is 7. Since the variable's on the top of the fraction, we'll just multiply both sides by 7. Oops. Hard time. And the 7, and the 7's will cancel, and we'll get sine of b is equal to 7 times the sine of 35 divided by 6, and you get 0.669, and then sine inverse of that, and you find that angle B is going to equal 42 degrees. Now, because the angles have to add up to 180, we know that angle C is going to be 180 minus 35 minus 42, or 103 degrees. And we can find side C. So these are all for the big triangle here. So side C, sine of 35, sine of A, I guess I'll do this in another color, sine of A, sine of 35 over A is going to equal sine of 103, that's the sine C over C. Cross multiply, and you get C times the sine of 35 equals 6 times the sine of 103. Divide both sides by the sine of 35, and you get C is equal to 10.2. So we just solved for the large triangle. That's one of the two triangles. Now, the second triangle is actually a little easier to get. I need to go to a blank screen, but remember that B was 42. So we're going to go to A. So we're going to go to, and we're going to start that one again, and we're going to say, all right, well, we know that A is equal to 35, and our side A is equal to 6, and our side B is equal to 7. Okay? And in this case, this angle here is going to be the supplement of the other B, because you can picture it. This was the original triangle. This was 42. That makes this 42, because this is an isosceles, because these are both 6. Since this is our A angle, if this was 42, then this has to be the supplement to it. And so in this case, this angle B is going to be 138 degrees. And so now we know that angle A is 35, that was given. Side A was given as 6. Angle B is 138, oops, B. Side B is 7, that was given. Angle C and side C are all you need to find. And you can find angle C because you know that this column has to add up to 180 degrees. So 180 minus 138 minus 35. We know that side C, angle C is 7 degrees. And so we can use law of sines to find side C. And you find that C is equal to 1.3. And there's the work for it. Number 5, a mathematician is walking in the woods. She notices that there's a 45-degree angle to the little bird up here in the tree, right? There's my little bird, here's my mathematician. The mathematician walks 30 feet towards the tree, and then notices that the angle of elevation is now 60 degrees. And here's my tree. Okay, so that's my picture. And the question is, when she's standing here looking up at the bird, how far is she from the bird? So it's that leg that we're looking for. All right, so we'll call this angle A, and we'll call this side A. So we're trying to find A. We'll call this angle B. Now, this 60 degrees is outside of our triangle. We want to have this angle. That's the supplement to the 60. So we know angle B is 120 degrees. We know angle A is 45 degrees. We're looking for side A, and we have angle C up there. We know side C is 30, and we can find angle C because angle C has to make all of our angles add up to 180. So angle C will be 15 degrees. And now I can use law of sines to find A. Sine of C over C equals sine of A over A, which means sine of 15 over 30 equals sine of 45 over A, and A is equal to 81.96 feet. Here are some students doing the next problem. Okay, in this problem we have a person walking their dog, and the dogs take off, and the speed that they take off at is 10 meters per second and 8 meters per second, and they run for 5 seconds. So, and the angle between the dogs is 25 degrees. So we have our person, and here's the 25-degree angle, and one dog ends up over here, and one dog ends up over here. And we can figure out those distances because the distance they run is the speed times time. So if one dog runs for 10 meters per second, if I multiply that by 5 seconds, then that dog's going to go 50 meters. So one length's going to be 50 meters of my triangle, and the other length will be 40 meters. Multiply that by 5, and this length over here will be 40, dog number 2. So here we have our 2 locations, and we're looking for this distance. Okay, so we'll call this A. Oh, I guess my person should have some arms. Not the best at that. Dog walker. So we have, we'll make this angle A, and this will be angle B, and this will be angle C, and so this will be side C, this will be side B, and this will be side A. And you can use the law of cosines. A squared equals B squared plus C squared minus 2BC cosine A. And if you plug everything in, you should get that the dogs are 21.8 meters apart. And the last 3 questions, you don't need to do number 7. Number 8, 9, and 10, you can look through your notes, and we talked about those in class, so I won't redo them here.